You are sitting at a traffic light in the middle of a brutal summer afternoon. The sun is beating down through your windshield, the steering wheel is almost too hot to touch, and your shirt is starting to stick to your back. You turn your AC to maximum, expecting relief, but instead, what comes out of your vents feels like a weak, warm breath. Not cold, not refreshing, just air, barely doing anything. And in that moment, most people assume the same thing. Something expensive just broke. That assumption is exactly what the entire automotive repair system is built on. Your dealership is going to tell you that your refrigerant is low and you need a $150 recharge. Your local mechanic might escalate it further and warn you about compressor failure, quoting anywhere from $800 to $200. And because you're uncomfortable, frustrated, and not thinking about airflow physics in that moment, you believe them. You approve the inspection, you authorize the repair, and just like that, a simple problem turns into a high-ticket invoice. But here is the reality that almost no one tells you. Your AC system is not broken, it is suffocating. There's a single component inside your vehicle, hidden behind your glove box, that controls the airflow your entire cooling system depends on. When it becomes clogged, it doesn't matter how powerful your compressor is or how fresh your refrigerant is, the system physically cannot breathe. The evaporator coil cannot exchange heat properly. Cold air cannot circulate, and the entire system chokes under its own restriction. That component costs around $8. It takes less than 6 minutes to replace, and it requires absolutely no tools. Yet repair shops rarely mention it first. Not because they don't know, but because once you understand what that small filter does to your system, you start asking dangerous questions. You start realizing that you've been paying hundreds of dollars for something that could have been fixed in your driveway in under 10 minutes. And this isn't a new discovery. This was solved decades ago. To understand how this became hidden in plain sight, you have to go back to 1954, when Toyota Motor Corporation made a decision that quietly shaped the future of automotive engineering. They created a specialized division in Korea, Japan, Nippon Denso, with one clear mission: to master thermal systems, airflow control, and climate engineering inside vehicles. This wasn't just another parts supplier. This was a precision engineering division focused entirely on how air moves, how heat transfers, and how systems stay efficient over time. And one of their most important innovations wasn't a compressor or a refrigerant upgrade. It was something far simpler: a layered cabin air filtration system designed to protect airflow. Because the Japanese engineers understood something most people still overlook today. An HVAC system is only as powerful as the air that can pass through it. Restrict the airflow, and you don't just reduce performance, you collapse the entire cooling process. Now here's where it gets interesting. Fast forward to today. You walk into a dealership and ask for a cabin air filter for your car. They hand you a branded package, often labeled under Toyota Motor Corporation or another OEM brand, and charge you anywhere between $20 and $40. It looks official. It feels premium. It carries the weight of the manufacturer's name. But if you open your car's airbox and look at the filter already installed inside, you'll often see a different name printed directly on the frame. Denso, the original manufacturer, the exact same company that engineered the system in the first place. And that same filter, built with the same multi-layer design, the same airflow specifications, and the same filtration structure, is sold independently under Denso Corporation branding for around $7 to $8. No difference in performance, no difference in materials, just a different logo on the packaging. That means the dealership isn't selling you better engineering. They are selling you branding at a 300-400% markup. And once you see it, you can't unsee it. Because this isn't just about a filter. This is about how an entire system, mechanical, financial, and psychological, has been structured to keep simple problems looking expensive. And in the next section, you're going to see exactly how that system turns an $8 airflow restriction into a $200 repair bill, and why it keeps working on millions of drivers every single year. Now this is the moment where everything changes, because once you understand what is actually happening inside your dashboard, no mechanic, no dealership, and no service advisor will ever be able to mislead you again. Deep inside your car's dashboard sits a component most drivers never see, yet it controls the entire cooling experience of your vehicle. It is called the evaporator coil. This is not just a random metal part, it is a precisely engineered thermal exchange system built from thin aluminum fins, tightly packed together, carrying refrigerant that operates at temperatures between 32 and 40 degrees Fahrenheit. That means every second your AC is running, this coil is sitting there ice cold, ready to absorb heat. Here's how the system actually works. Your blower motor pulls warm air from inside the cabin and forces it across those freezing aluminum fins. As that air passes over the coil, the refrigerant inside absorbs the heat energy, rapidly cooling the air before it gets pushed out through your vents. That is the moment you feel cold air hitting your face. It is not magic, it is heat transfer, it is physics, and it is extremely precise. Engineers at Toyota Motor Corporation and Honda designed these systems around a concept called delta T, which simply means temperature difference. This is the gap between the temperature of the air entering the system and the temperature of the air leaving it. In a properly functioning vehicle, that difference is engineered to fall between 18 and 25 degrees Fahrenheit. Not more, not less. That range is the result of exact calculations involving compressor output, refrigerant pressure, fin density, and most importantly, airflow volume. And this is where everything starts to break. Because what dealerships never explain is that every single cubic foot of air your system moves must pass through one single point before it ever reaches the evaporator coil, the cabin air filter. That filter is not optional. It is not secondary. It is the gatekeeper of airflow. And when it starts to clog, everything changes instantly. A clogged filter can reduce airflow by 25 to 40%. That means even though your evaporator coil is still freezing cold, there's not enough air passing over it to carry that cold into your cabin. The system becomes choked, suffocated. The air coming from your vents feels weak, inconsistent, and slightly warm, not because the system failed, but because the air cannot physically move through it anymore. Your AC responds the only way it knows how. It runs longer. It works harder. It burns more energy, trying to compensate for a restriction it cannot overcome. And that is the exact moment when most drivers are told they have a major problem. But now you understand the truth. It was never the compressor. It was never the refrigerant. It was airflow. And once you see that, the entire system starts to make sense. Now, let's go even deeper, because not all filters are the same, and this is where chemistry quietly takes control of your air quality. The cabin filter inside your car is not just trapping dust. High-quality filters, especially those manufactured by Denso Corporation, include a layer of something far more advanced, activated carbon. This is not the same charcoal you see in a barbecue grill. Activated carbon is engineered in a controlled environment where organic material is heated to extreme temperatures between 600 and 1200 degrees Celsius in an oxygen-limited chamber. This process creates a structure filled with millions of microscopic pores, tiny cavities that dramatically increase its surface area. And here's the part that most people cannot even visualize. Just 1 gram of properly activated carbon can have a surface area between 500 and 2,500 square meters. That is the equivalent of covering an entire basketball court with a material that weighs less than a paperclip. This is what allows it to trap contaminants at a molecular level. But the way it works is even more important. Most people think filters absorb pollutants. They imagine liquids soaking into a sponge. That is not what happens here. Activated carbon uses a process called adsorption with a D. Instead of soaking substances in, it binds them to its surface through chemical attraction. Odor molecules, volatile organic compounds, exhaust gases, these particles stick to the carbon permanently, locking themselves onto those microscopic surfaces. This is not theory. Research published in the Journal of Hazardous Materials in 2018 demonstrated that activated carbon filtration can remove up to 90% of volatile organic compounds from airflow. That means every breath you take inside your car is being chemically filtered at a level most people never even consider. But here's the hidden limitation, the part almost no one talks about. Activated carbon does not last forever. It has a hard chemical limit. Every microscopic surface inside that carbon structure eventually fills up. Every binding site gets occupied. And once that happens, the carbon stops working completely. It does not regenerate. It does not reset. It becomes chemically dead. Under normal driving conditions, especially in cities with pollution, dust, and traffic exhaust, this saturation happens between 12,000 and 15,000 miles. After that point, the carbon layer is no longer removing odors. It is no longer trapping harmful gases. It is just sitting there, doing nothing. And if you continue driving to 30,000 miles without replacing it, you are essentially pushing air through a dead filter for an entire year. The airflow is restricted, the chemical protection is gone, and something even worse begins to develop. Moisture, organic buildup, biofilm. Inside your evaporator coil, where condensation naturally forms, mold begins to grow, bacteria start to accumulate, and now instead of clean, cold air, your system is circulating contaminated air directly into your cabin. At this point, the problem is no longer just comfort. It is performance. It is efficiency. And it is the quality of the air you breathe every single day. And in the next section, you are going to see the exact 6-minute protocol that resets this entire system, restoring airflow, restoring cooling performance, and eliminating the problem at its source without spending hundreds of dollars. In 2009, a fleet manager named Kei Fujiwara was responsible for maintaining 87 vehicles operating as taxis across the dense, polluted districts of Osaka, Japan. These were not luxury vehicles, they were workhorses, mostly Toyota Corolla, Axios, and Crown Comforts, running almost non-stop through traffic, heat, and heavy urban air contamination. And over time, something started to go wrong. not gradually, but repeatedly. Within a span of just 14 months, 6 of those vehicles suffered catastrophic air conditioning compressor failures. Each failure came with a repair bill ranging between $800 and $200, including parts and labor. For a commercial fleet, this wasn't just inconvenient, it was financially destructive. The air conditioning system, something meant to provide basic comfort for drivers and passengers, was becoming one of the most expensive liabilities in the entire operation. At first, the assumption was obvious: wear and tear, heavy usage, long hours on the road. But when the pattern continued, Fujiwara escalated the issue and brought in a field representative from Denso Corporation to conduct a full diagnostic review. Service records were analyzed, maintenance intervals were compared, failure timelines were mapped out across all affected vehicles. And what they discovered was not a complex mechanical defect or a manufacturing flaw. It was something far simpler and far more alarming. Every single vehicle that experienced a compressor failure had one thing in common. The cabin air filter had not been replaced in over 18 months. That was the trigger. Not the compressor design, not the refrigerant, not the system architecture. A neglected, clogged filter, hidden behind the dashboard, was quietly initiating a chain reaction that ended in total system failure. And once you understand how that chain reaction works, the entire system becomes impossible to ignore. It starts with the filter. Over time, it fills with dust, particulate matter, and a saturated layer of dead activated carbon. What was once a breathable pathway for air slowly becomes a dense barrier. Airflow drops dramatically. The system becomes restricted. And the moment that airflow decreases, everything downstream begins to suffer. The blower motor is the first to react. Its job is to push air through the system, and when resistance increases, it compensates by working harder. It draws more electrical current. It spins under higher load. What used to be an effortless flow becomes mechanical strain. That strain doesn't stay isolated. It spreads. The increased electrical demand places stress on the vehicle's electrical system, particularly the circuits connected to the HVAC system. The compressor, which depends on stable electrical input and consistent cycling, begins to behave irregularly. Instead of operating in smooth, controlled intervals, it starts to short cycle, turning on and off unpredictably under unstable load conditions. This is where the real damage begins, because compressors are not designed to operate under erratic electrical stress. Internal components heat up, lubrication becomes inconsistent, pressure imbalances start to form within the system. And over time, what began as a simple airflow restriction escalates into full mechanical failure. That is the cascade. A single clogged filter triggers a sequence that ends in a destroyed compressor. And once it fails, the cost is no longer $8. It is $1,100. After identifying this root cause, Fujiwara made a decision that changed everything. He implemented a strict maintenance protocol across all 87 vehicles. Every single cabin air filter would be replaced at a fixed interval of 12,000 kilometers. No exceptions, no delays, no negotiation. It was a small operational change, but it targeted the exact point where the failure chain began. The results were immediate and undeniable. In the 18 months that followed, the fleet experienced 0 compressor failures. Not fewer, 0. The problem that had been draining thousands of dollars from the operation disappeared completely. Not because of a redesign, not because of upgraded parts, but because of a simple, consistent maintenance practice focused on airflow. And here's the part that reveals the deeper truth. The repair shop that had been replacing those compressors lost the fleet contract shortly after, because once the real cause was identified, the entire business model collapsed. A $1,200 repair generates profit. An $8 preventive replacement does not. And that is why this knowledge is rarely emphasized, because it removes the need for expensive fixes. To fully understand why this system was perfected in Japan long before it became standard elsewhere, you have to look at the environment these vehicles were operating in. Cities like Osaka, Tokyo, and Nagoya in the 1990s were among the most densely populated and heavily polluted urban environments in the world. High concentrations of PM 2.5 particulate matter, nitrogen dioxide, and industrial emissions created conditions where air filtration was not optional. It was critical for both performance and human health. Engineers at Denso Corporation were forced to solve a problem that Western markets had not yet fully experienced. They developed multi-layer cabin filtration systems with integrated activated carbon layers, capable of handling extreme air contamination while maintaining consistent airflow. By the mid-1990s, these systems were already standard in many Japanese vehicles. Meanwhile, Western markets did not widely adopt similar filtration standards until the early 2000s. The technology was engineered in Japan out of necessity, but the pricing strategy, the markups, the branding premiums, the inflated replacement costs, those were built elsewhere. And once you connect all of this together, the pattern becomes impossible to ignore. A simple, overlooked component controls airflow. Airflow controls system efficiency. System efficiency determines component lifespan. And ignoring that, one component sets off a chain reaction that turns an $8 problem into a 4-figure repair. And in the next section, you're going to see the exact step-by-step driveway protocol that prevents this entire cascade from ever starting, giving you full control over your system in under 6 minutes. Now that you understand the physics, the chemistry, and the real-world cost of ignoring this problem, the final step is the easiest part of the entire process. This is where the dealership loses control of the story, because this is the moment where you fix the problem yourself in your own driveway, in less time than it takes to wait in line at a service counter. And the first rule is simple: do not go to the dealer. Go directly to Amazon or Rock Auto and buy the actual Denso filter yourself. That is the original manufacturer in many Toyota and Honda applications, and it is the exact same engineering without the inflated logo tax. For a Toyota Camry from 2018 to 2024, the correct filter is the Denso DCF 332K. For a Toyota Corolla from 2020 to 2024, use Denso 454-5057. For a Toyota RAV4 from 2019 to 2024, use Denso 454-5061. For a Honda Civic or CR-V from 2016 to 2024, use Denso DCF 075K. These typically cost between $7 and $9. At the dealer, the same equivalent filter usually costs between $28 and $40. That means before you even touch your glove box, you have already beaten the pricing game. The actual replacement process is so simple, it almost feels insulting once you realize how many people have been overcharged for ignoring it. Start by opening the glove box fully. On most Toyota and Honda models, all you have to do is press the sides of the glove box inward so the plastic stops. Clear the dashboard frame, then gently pull downward. The glove box drops out of the way. No screwdriver. No socket set, no trim tool, no mechanic. This is the part service departments do not like you discovering, because the first step of the repair takes about 5 seconds and requires nothing but your hands. Once the glove box is down, you will immediately see a small rectangular filter housing behind it. That is the access point. Squeeze the 2 side tabs on the cover and pull it straight out. It opens almost instantly. Now slide the old filter out slowly and do not rush this part, because this is where one small mistake can ruin the entire installation. Before you throw anything away, look carefully at the side of the old filter and find the airflow direction arrow. Take a photo of it with your phone. That single photo protects you from installing the new filter backwards, which is one of the few ways people turn a 6-minute fix into a frustrating second attempt. Once it is out, inspect it closely. If the filter is dark, gray, or black, if the pleats are packed with dust, leaves, hair, and debris, or if the activated carbon layer looks matted, damp, or flattened, then your system has been struggling for far longer than you realized. That filter has not just been dirty. It has been starving your AC, restricting airflow, and quietly forcing the entire HVAC system to operate under stress for months. Now take the new Denso filter and install it in the exact same direction as the old one, using the airflow arrow as your guide. In most cases, that arrow will point toward the cabin, but the correct answer is always whatever direction the original filter was facing, which is why the photo matters. Slide the new filter into the housing, close the rectangular cover until it clicks securely into place, then lift the glove box back up and push it inward until the side tabs snap back into position. That is it. Total time elapsed. For most people is between 4 and 6 minutes. No appointment, no labor fee, no diagnostic charge, no waiting room coffee, just restored airflow. But there is one final move that makes the result feel immediate, and this is the part almost nobody talks about. Once the new filter is installed, start the car and turn the air conditioning to maximum fan speed. Then switch the system to recirculation mode and let it run for exactly 3 minutes. That newly opened airflow pathway allows the evaporator coil to operate the way it was originally designed to operate, at full airflow capacity, without restriction, without suffocation, and without dead carbon blocking the system. In many cases, the difference feels almost instant. The airflow gets stronger, the temperature drops faster, and the cabin begins cooling the way it should have been cooling all along. For the average driver, it feels like the AC suddenly came back to life. But the truth is even more satisfying than that. It did not come back to life. It was never dead. It was being choked. Toyota and Honda engineers designed these HVAC systems to operate at a very specific, mathematically controlled airflow volume. That airflow is not a minor detail. It is the entire foundation of the system's cooling performance. The cabin air filter is the only thing standing between that engineered performance and the weak, stale, underperforming air that millions of drivers have slowly accepted as normal. In less than 6 minutes, you restored that airflow. You restored your cooling efficiency, you reduced strain on your blower motor and compressor, and you did it all for the price of a fast food meal. You did not just make your car colder, you protected one of the most expensive components in the entire climate control system with an $8 decision the repair industry almost never leads with. And that is why this matters so much. Because the $18 billion automotive service economy depends on drivers not understanding simple cause and effect. It depends on confusion. It depends on hidden access points, vague diagnoses, inflated fear, and the assumption that every comfort problem in a modern car must be expensive. But now you know better. You know that airflow is everything. You know that a clogged filter can trigger a cascade of performance loss and mechanical stress. And you know that the fix was sitting behind your glove box the entire time. Subscribe to this channel and share this video with every Toyota and Honda owner you know who is sweating through their commute right now, because next week we are covering the $3 Japanese compound that neutralizes and helps prevent evaporator mold permanently. And that video is going to make this one feel like the introduction. The dealer knows it exists. Now you do too.